Okay, your lab start this week also. No, for this module, start week 7 after Chinese New Year break, right? For this module. Okay. We are now in week 3. Your test will be after Chinese New Year also. Huh? Okay, so these slides you have seen 2n square. Yes. Any question? Yeah.
Is it the whole of 2n?
2n square. Yeah, 2n square. This one is number of electron. Huh? Don't confuse with the number of orbit. Huh? Number of orbit is n square. Number of electron is 2n square. This is to calculate how many car park you have for that particular orbit, that particular principal orbit. Huh? Okay. Previously, we introduced you something called electron configuration and orbital box diagram. Means that electron configuration is SPDF. So each one will give you a number. So if you a number. So for example, oxygen. Oxygen, how many electron in the orbit? How many electron in the orbit? 8. From the periodic table, where is oxygen? It's over here. So number 8 is number of electron it have. How do you write electron configuration? So 8 electron. So you know want to find how we park this 8 electron. Okay. So for the first orbit is 2, right? Because 2n square is the maximum of particular shell. First orbit will be 2. Second orbit will be 8. Okay. So you need to park the electron first from the lowest to you park 2, remaining you have 6. So 6 will park in the second highway. Okay. So for hydrogen, you write 1s2, then the 6th one. In second orbit, number 2, you have S and P. Yeah. Previous class, we already teach you how to write for 2 already. Yeah. For 2 is 0 to L. For 2, 0 to L, you have 1 and 0 and 1. Means you have S and P. Remember? No. And principal. You have 1. So equation to calculate number of orbit is n squared. So if n is 1, you only get 1. If n equal to maximum orbit you have will be 4. And so on. And 3, you have 9. This is orbit. Number of electron is what? 2n squared. This one have 2. This is max. This is 8. This is how many? 16. Right? 2n, n is 9. 9 multiplied 2 is 18. Okay. Then suborbit. How you know you have how many suborbit? Suborbit equation 2L, sorry, 0 to L. And what else? This one, 2L plus 1, right? Sorry, n minus 1. N minus 1 is what? Number of subcell. Number of subcell. N minus 1. So this one equal 1 will be 0, no subcell. So 2, we have 1 subcell. N minus 1. Sorry, n minus 1. So 0, this one, 0 to 1. This one, 0 to 2. What does it mean? 0 means 0. S, P, D, F, 0, 1, 2, 3. So you only have S. Here you have S, P. Here you have S, P, D. Then how many lane you have for each one? You use what? L plus 1. Sorry, 2L plus 1 to represent how many orbit you have. So this one, S has how many orbit? 1 orbit means 1 lane. This one, S, this one to calculate. This one actually for SPDF. S got 1, P, 0, 1, 2, 3. P you have 3, 2 you have 5, 7. So SP, S got 1, P got 3. This is how you get 4. 1 plus 3, 4. How you get 9? 1, 3, 5. 1 plus 3 plus 5, you get 9. Okay, I'm familiar with all this formula. You go to oxygen. Oxygen give you 8 electron. Maximum electron you can put into the orbit. N1 maximum 2, N2 maximum 8. Got 8 electron parked here already. Parked in lane 1. This one taken. Balance is 6. So you write what? 1s. 2. You park 2 already. Then remaining 6. After S, go to what? P. P got how many lane? 3 lane. So 2. Got 2 lane. So this one got S. This one got S and P. So you have 2S, 2P. P you have P1, 2, 3. Right? So S you can fit 2 only. Okay? S you can fit 2 only. Remaining, how many? 2 lah. Sorry, 4. Because you have electron to solve. 8 car here. You want to park the car. So first orbit, you only have 2 parking spaces. But you go to the second highway, you have 2 stop lane. If you go to second highway, you will see S subway and 3P. So you go here, 2p, 4. Each one can park 2 cars. Okay, here you can only park 2 cars. So you got 8 cars to park. Park this one, park this one, park the lowest one S, then distribute. Okay, this is how you write 1s2, 2s2, 2p4. For electron configuration, this is the first presentation. Another configuration will be orbital box diagram. Last lecture, we stop here. You convert 1s into 2 box, 2s into 2 box, 2p into 6 box, but 2 car park, 2 car park, 2 car park. Why 2p got 6 car park? Because p got 3 lane. 2l plus 1. P is 3. So you got 3 car park. Yeah. How you park the car? Park the left-hand side first, then right-hand side. You park the left-hand side first. For example, the first one. First one, normally you park 2 cars first. Then you go to 2S. Park the 2 cars first, park the left-hand side, then right-hand side. Remember, the arrow must be opposite direction. Don't put 2 directions same. 2 direction, you will make the molecule to shift because it's rotating. Okay, we are assuming the molecule is stable, right? So 2p, you have four left to park. Park the left-hand side first. Park the left-hand side car park. So you'll see the going up arrow got 3. Then go back to the lowest car park. That's why you see 2 arrow at this 2p left-hand side. Got 2 them. So there's a sequence how you park the car. Always fill in the left. Then if left is taken, fill in the right. This is the first highway. Second highway, fill in the S first. Another 2. 3p got 3 lane or 3 car park. It got 6 car park. Got 3 lane. Fill in the left-hand side first. Fill. Then there is one more here. Remember, left-hand side always pointing up. Right-hand side always pointing down. The arrow is important. Left-hand side always pointing up. Right-hand side always pointing down. So there are 2 types of presentation: electron configuration and orbital box diagram. So the question will force you to represent, let's say, it asks you to write the electron configuration for oxygen, present your answer, or support your answer with orbital box diagram. It means you need to write SPDF equation plus this orbital diagram. Okay. Understand? Now we go to one more example, nitrogen. Nitrogen, on the graph, where is nitrogen? Can you spot nitrogen? You go for the first row, then second row here. What is the electron? 7. So same. 7. Nitrogen got 7. So 7, you know that maximum electron is 2, 8. So you cannot go more than 3 orbitals or 3 primary orbitals. So you fill in the first one, 1s will be 2. Then you go to second one. Second one start with S. S always 2. Then you go to P. Here you can fit 8 electron there, or 8 car there. You have 7. Fill in 2, balance 3. So for nitrogen, electron configuration will be 1s2, 2s2, 2p3. How to draw the orbital diagram? Same, convert S into 2 kappa. 1 go up, of course, right, 1s lah. Okay, 1s, label the kappa space, 1s, 1 go up, 1 go down. Then draw 2s, 1 go up, 1 go down. Mistake will be here. 2p, you got 3 lane. Each lane can park 2 cars. Fill in the left hand side first. You got 3 electron, got 3 kappa. Left, left, left. Don't squeeze the space. Fill in the left hand side first, then only you fill in another one. So if you understand this one, you should be no issue lah. So I show you the answer lah. This will be the answer for nitrogen. Okay, can Too easy, right? Okay. The other you see, you look as a reference. Hydrogen only have 1, helium has 1, lithium has 1, barium have 2, and so example. I will give you a cheat code later on drawing the diagram here. There's a cheat code. So this example, can you write the electron structure, electron structure of titanium using orbital box? So usually you cannot run away from the SPDF, then only you convert lah. Okay, titanium. Where is titanium? Can you find it? Titanium? Pi? Row number 4. Okay. Got 22. So you know, if you're able to build this table, 22. Here already take out the 10 electron. 8 plus 2 plus 8, 10. Here got 18. So you cannot go more than n equal 3. So it depends on how you park your car lah. Okay. So can you write the electron configuration first or not for titanium? You got 22. So 1 S 2 already standard already. 2 S 2 2 P 6 or 6 ma. Okay, so you take up already 2 plus 2 plus 6, 10. You get another 12. Continue. 3 F 2 3 P 6. Then D. What's the number? Here 10 already. 18. D 4. Okay, D is 4. So you know how to convert this one to kappa, right? 2, 2, 6 means 2, 2, 2. This one, 2, this one, 2, 2, 2. And this one got 4. You need to draw 4 box here, 8 box here. Then fill in the left hand side. Yeah. Again, go and download the tutorial question. If can, it will help you in the class. Because in the tutorial, you will see the periodic table. You'll see the exact tutorial table, periodic table in the test. Okay. Okay. So this one already explained on the whiteboard. Okay, I give you the cheat code. There's a cheat code. Every time you go to periodic table, this is n number 1, right? N number 1, number 2, number 3, number 4. You only need to put in some notes on the periodic table. Straight away, you can write SPDF equation already. The first one, first row is S. Means this one is 1 S. Means if for hydrogen, 1s1. Helium, 1s2. Okay, so row number 1, row number 2. Second one, N2. This one is 2s2, 2p6. How you know is P? I give you all. Do you see the highlight at the bottom? Okay. S is over here. Just mark on the predict. Every time you see this kind of question, you go to your predict table, mark this row is S. Then go to the bottom of the graph, label, highlight these two is S. Highlight this gray color to the N is P. Label here, this color, dark color to this dark color is D. What else? So once you label S, S, P, D, you can straight away from a periodic table read the SPDF equation. For example, oxygen just now is here, right? Oxygen is location here. So you read the first row, you write 1s2. Then it complete from here, right? Here to here. So here is, you count lah. Here is 2s. 2s square. Then here is 1, 2, 3. That's under what? P. So 1, 2, 3, 4. 2p4 for oxygen. For titanium, here. You go lah. First row, you write 1s square. Second one, you write 2s square, 2p6. How you get this number? This whole row, it represent 2s plus 1, 2, 3, 4, 5, 6. This whole is p. Number 2, p6. Titanium over here. Again, this one is what? Number 3 also here. Number 3, don't miss out this one. Number 3, you need complete 1, 2. Is 3s. Then 1, 2, 3, 4, 5, 6. 3p6. Titanium. Again, this one is 4. 4 is what? 4s2. Complete this one already. 1, 2. So 4p what? 2. And that's the answer. Okay. So a bit, this is wrong. Why I write 4 here? Okay. So this one is a bit wrong because this is based on simple calculation. When you're referring to table number 3, it will jump. You see, this question, it will jump not to 3D because number 3 don't have D. Number 3 don't have D. It don't go to the D. Number 3 don't have D component here. But in the early predict prediction, we write D here, wrong. Because of energy level. This is based on simple calculation. This is wrong. It to refer to periodic table because number 3 don't have D family. It will give to number 4 first. So the answer will be, this one is wrong, will be 4S2 D2. 4D2. The full answer is this one. This is a long answer for titanium. 1S2, 2S2, 2P6, 3S2, 3P6, 4S2, 4D2. This is a long answer. You might ask, Dr. Ang, is there any short answer? Yes, there is a short answer. How to write the short answer? You can represent 1S2 until 3P6 as one element, argon. You can write as argon, continue, write 4S2, 4D square. Presentation is bracket, what is the element, plus the remaining electron. So that you don't need to write a very long answer. Makes sense? Makes sense, huh? So this element, always the last member. You cannot anyhow pick any members. It must be a complete members at group number 8. Stable members. Octa, call it what? We call it stable or argon gas. Stable gas. So this one, important is this one. Don't anyhow go and pick one. This one, you should always choose the member over here. Member at group number 8. Stable member. Yeah. So of course, if the question asks you what is argon, what is argon electron configuration, don't write this one. If the question asks you argon, don't write like that. This is wrong answer. You should write 1S squared. This one. This one wrong. If you give back the same answer wrong. You should write the extended one. Don't cheat until like this lah. Understand? Okay. So by giving this cheat code, you should be able to solve any SPDF question. You don't need to memorize the SPDF. You just need to refer to this graph. Right, where is S? Right, where is S? Where is P? Where is D? Some of you might remember these two wrong. Then wrong. Okay. S, P, then only D. Okay, then add in some notation just in case you forget. This one is 3D, 4D, 5D, 6D. Sorry, this one is wait, something wrong on my slides. This one should be 4D. This one should be 4D. 4D, 5D, 6D, so on. This is wrong. It should be 4. What's this root? Number 4. Wait. Let me check. There's the answer. Correct. This one is 3. For D is 3. Correction. Correction. This one, make a remark. This is 3, 4, 5, 6. I make a mistake in my answer. Take note. Take note. Just now I missed out this one. This one is the more correct one. So S, P, D, then remind yourself this middle one for the D. Count the top one as 3, second one is 4, this one 5, this one 6. So the correct answer for the titanium is not 4s2, 4d2. This is wrong. The answer will be argon bracket 3d2, 4s2. Why? Where is titanium? Here is under 3D dimension. So 4, 2s, but here 3D, 3D1, 3D2. Makes sense? Makes sense, huh? Just need to make note this one. This one start from 3, this one 4, this one 5, this one 6. Even though this one is row number 4. Okay, yeah? Because of energy level. So we have made a few mistakes just now. So this one, again, correction. It's not 4s2, 4d2, but make this one as 3d, 4d, 5d, 6d. Yeah? This one usually is the careless mistakes in the exam. Okay, correct answer is this one. Argon, 3d2, 4s2. You can make your okay, another one. This one, bottom one is 4f, 5f. Okay, add another 2 nodes in the diagram. D, 3D, 4D, 5D, 6D, then add another one because SPDF ma. So this is 4F, this is 5F. It not there. Just in case the question asks you something inside here, like for example DI, DY, ND, CE, cesium, PU. So you just write accordingly. Okay. And these 2 dotted line, there is a meaning. Dotted line means it's fit inside here. It's within this gap. Okay. Okay, okay, this is a cheat code as PDF. Yes. Yes. No, this is orbital number 6, number 7. Orbital 6, orbital 7. This is N number. This is fit under. Oops. This is fit under. This is 6, 7 is orbital number, which is the same fit inside here. It's a different material. It's a special material. That's why they put this element out, then joining this element. It's a special element. So they pull this element outside, but their electron is fall under 4f and 5f. Okay. Okay. So this table in my PowerPoint slide is your checklist lah. If you want to check whether you understand or not, let's say you pick zinc and you try to use the cheat code, see whether you get this answer or not. This is the correct answer. This is the correct thing lah. So for example, titanium. This titanium. Here, titanium, the answer is here. Yeah. So it's inside my slides. This is another presentation. Just for your illustration. Important is this slide. The one that you see just now. Okay. Okay. Now we want to see by observing this periodic table, you should able to tell the size of the orbit, how it affect the electromagnetic behavior. Okay. So first, the size of the atomic. Size of atomic. So size of atomic, this one you read lah. Size of atomic, this one metallic radius means the metal component. In the periodic table, already label for you. Which one is metals? What kind of metals is it? So all those colored one, they are metals lah. So non-metals one is another color lah. Okay, this one you read. Okay, so metals one, they are metals. Then another one covalent. Covalent means non-metal. Like for example, oxygen, nitrogen, chlorine, they are using covalent radius. Okay. For metal, they are using metal radius. Mean the size. You got circle, circle got radius. So if it's a metal component or element, we refer the R or the size of the sphere as metallic radius. If it's not metals, then we use covalent radius. Actually, it's the same thing lah. It's just that if you use covalent, means it's a non-metal element. Okay. Now, you know that electron, this is Bohr models. So it depends on how many electron you have. Let's say periodic table, you know that your family 1, 2, 3, 4, 5, 6, 7, 8. Okay. And in chemistry, you know that 1, 2, 3, they are more easy to give away electron. Right? Family 1 means they have 1 electron outside, they're more easy to give away. Family 2 also same, more easy to give 2 electron. 3 also have, right? Then start from 4. 4 is, it depends on the mood lah. If got energy, it will give. If no energy, it will absorb. 4 is like half. Then 5, 6, 7, they have a very team bonding there. They don't want to give away. Normally 5, 6, 7 means family 5, 6, 7, because they have a loss of member. They want to pull member from outside. With this concept, means that if you only have 1, 2, 3, normally the size will be small because they give away already. They give away, then very small. Then 5, 6, 7, 8, they want to pull member from outside, they will become bigger and bigger. Means the force in the core will be stronger compared to the those family 1, 2, 3. Can So it just means if you look at the number above the element 1, 5, 6, 7, 8, 9, 10. Let's look at maybe row number 2. Row number 2, can you imagine the size if you move from the left to right? Lithium, 3. 4 means become bigger. 4 means 1 more electron, so orbit 1 bigger, right? So you can use SPDF if you want. This one is S. So this one got, let's say lithium. Lithium have 1 electron in 2s. This Be got 2 electron at 2s. So the size will be bigger a little bit compared to lithium, let's say 3 and 4. Then as you move to the right, it will become bigger and bigger and bigger. So the radius will be bigger and bigger and bigger. Okay, this is the size lah. So based on the n number or quantum number, how you know quantum number? At the left hand side of the periodic table, you see 1, 2, 3, 4, 5, 6, 7. This is principal number, quantum number. So as you go more and more, and you move down, you become bigger and bigger. Okay. Okay. Now, then if you move down, it becomes bigger and bigger. Then you move to the left. Move to the left. As you move to the from left to right, you need to focus on the core, nucleus. How many positive charge is there? Positive charge, the proton. positive charge. As you move from left to right, proton charge will become more and more stronger. More and stronger means the magnetic is stronger. It can pull electron from outside. Okay. So just now I give it wrong already. Just now I say left to right become bigger and bigger, right? It's wrong. Become bigger and bigger is 1 from the top to bottom. When you increase the n number, if you move from the left to right because of the core magnetic attraction, the orbit will pull inside. The electron from the electron positive charge will pull electron nearer to the center. Okay, so here there's a statement here. As the nucleus increase, it becomes stronger and stronger, and it tends to shrink the size of the atoms. You try to pull the electron together. Okay, so the size of the atoms will affect the material properties lah. So you want to mix the left hand side, right hand side, it depends on the size and right. Okay. So again, this one, the bottom one, they are less predictable because less data. They are in the transition. They are always in the, you can find in the process, but after the process complete, normally this one you won't see. They will convert to another element already. Okay. So this is illustration of periodic table, periodic size. This is just a rough ideas of the sizes. Okay, so this slide is to tell you the atomic size. Atomic size. If you move top to bottom, it becomes bigger and bigger. If you move to the left to right, it becomes smaller and smaller. You cannot say smaller and smaller lah. It's just that the radius tends to become smaller and smaller because of the pulling force from the nucleus, the positive charge in the center. Okay. Another one. Ionization energy. Ionization energy, it means it throw away the energy, the negative charge. Okay. So ionization energy is the energy required to remove electron from its orbit. So what do you think? On the left hand side or right hand side is more higher? Which side is more higher? Right hand side, because left hand side is more easier. Family 1, 2, 3 is very easy to give away. But 5, 6, 7, and even 8, you want to pull electron from their member is very hard. So the energy will be very high if you want to remove electron from the family 5, 6, 7, 8 or on the left hand side. Okay. So this one in the chemistry, they will label 1E1 means first ionization energy. It will important for reaction. Important for reaction. So this just to show you, this one is 2 electron. It give away 1, so there is an ionization energy there lah. Okay. So this is a cheat code also to memorize the behavior or trend of ionization energy. So if you move from the left to right, it will be increasing. It will be more harder and harder to remove electron. Okay. Then this is a radius, atomic radius. So if you move down, it becomes bigger and bigger. So if you move from the left to right, it becomes smaller and smaller. This is an inverted arrow. You move from the left to right, becomes smaller and smaller. Also same as if you move from the right to the left, it becomes bigger and bigger. It's the same. Okay. Then you read from this table. From the diagonal top to the diagonal bottom, it will become more and more metallic material character. All right. So the darker gray, it means opposite lah. It means opposite, means this one from here to here become metallic. So reverse back. If you move bottom to the top, it means non-metallic become stronger and stronger lah. Okay. This is important for your revision. Okay, it's a cheat code. This is a presentation on the ionization energy. This one arranged by the periodic table. So for as you can see here, you can know that, for example, number 8 is quite high. To remove energy, remove electron from it. Okay, this is family number 8. Helium is quite high. Helium and hydrogen, they are quite special element. Quite special element. Okay, this one is just now is the first ionization. If it become second one, if you want to remove the second outer core electron, it means in chemistry, we will label 1E2 lah, second ionization energy. First one is you remove the first electron. If you remove the second one, it will become second ionization energy. Okay. The first one, you take 1E1, you take 1E2 become, you need more energy already. It's like playing games. So let's say this one got 2 electron outside. You remove one already. So this one become more positive already. More positive means what? This electron outside, the remaining one, will being pulled inside because stronger positive. This one will pull inside already. So pull inside, you want to pull it out, you need more energy already. This means by these slides, second ionization, it will be higher. It means because you pull the first one already, the core have become more stronger. Then the second one at the outside, it will pull to inside a little bit. So you need more energy to pull it out. The rest you read, as you read. This is oxidation numbers, positive and negative. This is on the corrosion. If you take corrosion subject later, this is important for the corrosion chapter. For example, however, for this one later, all this number will be given in the question. Okay. So another word just now is give. Then what about receive? Receive will use the word electron affinity. Affinity means affection. Affection means love, means attraction, right? Being together. So electron affinity or EA, it means its tendency to accept or pull electron from outside. So when you see this word in the question, don't panic lah. It just means the tendency of accepting electron. So family 5, 6, 7, 8, 5, 6, 7, they are more, they have a higher value of electron affinity. Means they're willing to take electron from outside. Okay. So again, this chart again, right? Electron affinity will be higher if you move from the left to right, because family 5, 6, 7 are at here. So you need your tendency to accept electron is higher if you move from the left to right. And the rest you read. Okay, so this one, if it is increased, it means more energy is released after accepting a electron. If it accept one electron, means there is energy release. You will release. You accept electron, it become hot. The thing will become hot. Okay, you accept, become hot, become more energy inside. So energy inside, you need to balance, you need to release energy. It's like a cooling effect. You pull, you need to balance, you need to release energy. So which group in a periodic table have the highest in electron affinity? Which higher group will be 7? This question is actually test you whether you understand or not. Which group? We only have 8 group of F group in periodic table. Group 1, 2, 3, 4, 5, 6, 7, 8. The most stable one is 8. 8 doesn't care what happened outside because it's already stable. Right? So the answer is 6 and 7. This one is it depends. But the optimum answer is 7A or 7. But 6 also can. It depends. Because sometimes they receive 2 electron and 1 go to get it stable. Okay, this one is negative oxidation numbers. So this one you read lah. So number of electron that an atom can gain is called negative oxidation. So in the element. So we call oxidation number. Oxidation number means number of number of electron the element can receive. Okay, so this one you see got 1.5 means 1.5 electron means you will share. You will pull 1, then you will share 1 pair, for example. This one 2 means you will pull 2. 1.9 means you will pull 1 and then share most of the another electron. Okay, negative oxidation number. It means you are sharing electron. This one electron negativity. This one for your reference. We'll use this number when it comes to chemical reaction later. Okay. Okay. 1 and 2, another word, we call it reactive metal, family 1 and 2, because they easily give away electron. We call it reactive metals, family 1 and 2, or group 1A and 2A. 1A and 2A. Only in this module, you will see the A behind the numbers. In normal physics, you won't see A. Or in chemistry class, you won't see A. You just mention one. Okay. They are electropositive. Electropositive means a tendency to become positive charge. Electropositive means tendency become positive charge. For example, family 1 and 2, they tendency to give away electron, right? So when they give away, you have a remaining positive charge inside there. So it just means its tendency to become positive or electropositive. Okay, so 1 and 2, when you give away electron, it becomes positive. The word for positive charge is called cation, C-A-T-I-O-N. Or you see some element, let's say A, positive, it means cation. Negative, what about negative? A negative is called anion. A-N-I-O-N, anion. Anion means negative charge. Cation means positive charge. Okay, how I remember? I remember the T shape. Okay. On the family 6, 7, 6, 7, their tendency to pull electron outside. They are called reactive non-metal. Their tendency to become negative. So the word for that one is called electronegative. Electronegative means tendency to burn negative. Why they can become negative? Because they like to pull electron outside. So they form anion. Anion, A-N-I-O-N. So most of the time on the left-hand side, family 1 and 2, in the process, you will see them become positive charge. Family 6 and 7, normally in the process, chemical process, you see that they will change, become negative charge. Okay. Then another name is called metalloid. Metalloid means it can become male and female, means that you can switch one. It can become positive charge, it can become negative charge. It can be metallic, it can be non-metallic. Normally this one is like group 3A boron. Metalloid, they call metalloid. Boron, this one. The rest is non-metal. So the rest is metal. Aluminium is metal and so on. Okay, metalloid. Metalloid. So silicon also same. Silicon, carbon, they are also metalloid. Then 5A, non-metals. And then there's some metalloid. So how you know metalloid already labeled in the periodic table based on the color. The important here is you understand what is metalloid, what is non-metal, what is metal. Okay. The rest you read. The rest you read. Move down, you will have more metallic behavior. Move to the right, it will become non-metallic behavior. That's it. Okay. How this kind of question can come out? By using SPDF explanation and become electropositive or electronegative, it will tell you whether the element will show metallic behavior or non-metallic behavior by moving the electron away or adding electron. The rest you read. Number 8 is noble gas. It's stable. Okay, stable. They will always have S2P6, the full maximum electron in the subcell. Okay, I think we have a short break here. Or you want to go straight? Then we stop at 11:30. Okay, another 20 minutes. Okay, we go straight. Okay, another one is called normal gas. This one you know. We will cover 2 more bonding. You know, primary bond, secondary bond, and covalent bond, all this. It's just a revision. Okay, the rest of it. Primary bond, they are stable states. 3 types of primary bond. You take metal, combine non-metal. Metal, non-metal become primary. Non-metal, non-metal also become primary. Metal, metal become primary. Okay. Primary means you only mix 2 kind of materials, either metal, metal, non-metal, or non-metal, metal. So what happens if you take metal and non-metal, you combine together? You take metal plus non-metal, you get ionic bonding. Okay, you take metal plus non-metal, you get ionic bonding. In the periodic table, already tell you which one is metal, which one is non-metal. So when you take metal plus non-metal, you get ionic bonding. So usually they have a last difference in their electronegativity. Electronegativity means tendency to become negative. Usually you take on the family 1, 2, 3 combined with family with 5, 6, 7. Become 8, you want to stable. Right? So 1 will mix with 7, 2 will mix with 6, 3 will mix with 5. Then become stable lah. They form ionic bonding. Okay. So just now, family 1 and 2, they are reactive metal. 6, 7, they are reactive non-metal. These two is depend how you mix them lah. Okay. This one is just an example. They take one example, metal lithium, Li, mixed with metal ferrum on the same family number 2 or principal number 2. So you have a Li electron negativity of 1, which is 1. Non-metal electron negative of 4. How you get 4? There is a chart for that lah. Okay. Okay. Yeah, so 1 and 4 you should able to understand. Ferrum, why got 4? Because ferrum is more easy to pull electron. The number is more easy to give away. You want it to pull very hard, so the number is very low, only 1. Okay. So lithium lose 1 electron, form cation. So Li cation or positive charge. So radius of Li decrease 2. What does it mean? Lithium, the SPDF, how do you write? 1 S2, 2 S1. So how to become positive? This one fly away. So if you draw the Bose model, Bose model, this Bose models, this is nucleus. So got 2 here, 1 already give away. So got 3 plus here, means they got 3 plus but 2 negative here. So there are more positive charge that's pulling the remaining 2 electron. Can you imagine? So if initially got 3, so got 3 positive to balance. But you give away already, the stronger inner charge will pull the remaining electron more inside. Radius becomes smaller. Okay, it becomes smaller. So if from point something to 0.06, it pulls smaller. Okay. Okay, why this reduction of size happen? Because of the charge lah. So after ionization, 1e1, you take out the first electron ionization. Frontier electron is no longer in N2, but in N1. Okay. Balance inside there got positive nucleus, so they will exerted stronger force to pull it inside. Yeah. So this will be the standard answer we expected you to explain why there is a reduction of size when an element become cation. This is a standard answer. You either memorize or you put in the keyword you elaborate. This one will be there lah, either final exam or test one. Yeah. Yeah, frontier means the first after you remove, this is the frontier already. This one become frontier. Initially, this is the frontier, but this one remove already. These two become frontier. You can say outermost. Yeah. Okay. The second point is the stronger force, because of the positive nucleus charge there. Okay. Then, after transfer, lithium will complete its outer electron structure and take the structure of normal gas helium. What does it mean? It dropped already, it become 2, right? 2 electron outside. It will take the form of helium. It will drop from here to here. So this is the statement here. It will take the structure of the normal gas helium. Means this one becomes stable, although it's a positive charge, but it's stable. Yeah. So lithium, that's why it is very reactive. It can be positive charge, means it's able to attract electron, but it itself is a very stable element. Okay. Lithium battery is very dangerous. So for example, ferrum, this one electron go inside here. What is ferrum SPDF? F, how you write? 1s2, 2s2, 2p, what? 1, 2, 3. This is 2s. 1, 2, 1, 2, 3, 4, 5. Yeah, 9, right? This SPDF for F. So it receives 1 electron, become anion, F negative. So F negative, the radius increase. Why increase? You imagine this one is ferrum. Outer got 5. 1, 2, 3, 4, 5. Extra member come inside. Inside got what? Inside got 9 positive. Outside after you add, you got 10 negative. Pulling force is 9. You imagine it can only catch 9 electrons. Now you add 1 more member. So it's like lost power already. It's like cannot control the outer one. So the radius become bigger. It become bigger because the positive charge is just remain there. It just can pull 9. So you have 10 means the electron is free to move. It's free to move bigger in the bigger space. So that's why the radius become bigger. No, positive cannot change one. The charge cannot change, fixed already.
Because of an increase on either polarity, because increase in radius, because being attracted.
Okay, so the previous one to become cation, because we remove one electron outside, means inside still have positive charge. This one you cannot change the positive charge, fixed already. Let's say you have, for example, this one, forum. You have 9 army there, or 9 police there, but now you add 1 more. You have 10 criminal there. The police will be very busy. You cannot catch all the bad guy. So the bad guy can run at a further area. Means the force here cannot capture all the element. It cannot sustain the electron. Means the pulling force is not enough to hold all the electron. It must distribute with all the electron here. So it become bigger because less control already. So if you remove, you remove means stronger forces inside, can control the remaining electron. So that's why it string when you remove electron. It will be happening like that. Okay. It takes some time to digest a bit. Right. So why they are here? So ferrum will become helium, complete its outer electron structure and take the form of it's not Ne. No, yeah, correct. Not helium, but ferrum become Ne. Right, become Ne. Okay. Again, if you move from the top to bottom, the size increase. If you move from the left to right, yeah, in general, it should be shrinking in general. But in this case, because it's received electron, the internal forces is stronger, is become weaker compared to the total electron outside. So the size will become a bigger a little bit. Not very significant, but the radius will increase a bit. When it receives electron. That is the thing. Okay. Don't confuse with the periodic table sizes if you move from left or right to the chemical reaction. We are now talking about chemical reaction. You add or you remove or you add electron. Don't confuse with the previous section. Previous section we are talking about the periodic table when they are at their natural state. Now we are talking about you add electron or you remove electron, become anion and cations. The argument here is the positive charge inside. The nucleus means you use this line here. Positive nucleus and negative nucleus is lost. The balance is lost, and the nucleus can have a stronger force on the electron. It's not shell. Shell is just an orbit. The argument point, the focus point is the charge here. Charge that there's a imbalance charges between the inner core and the outside electron. Yes, means the positive fixed already, means the outside electron is larger, the negative charge is larger, so it makes the electron more space or move to the bigger orbits, radius increase, because less attraction already, less attraction. It's like attraction. If you add more negative means less attraction, it will become further and further between the center and the electron, between the nucleus and the electron. Yes, for example, this one, frontier means outside one, what you see is if this one got 2, you remove 1, this is the frontier. If ferrum, just now, this one got 2, right? Got 2, so I got 3 electron originally, it removed, so this is a previous frontier. After it removed, this one become the present frontier. Okay. 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 Now, how you explain become anion and cation? There are 3 presentation. You have learned electron configuration as PDF. You have learned orbital diagram. This is what you familiar with at your secondary level education. It's called Lewis electron dot symbol. You use dot and cross sometimes. Okay. So don't confuse this one and the 2. in this module, we are focused on electron configuration and orbital diagram. Unless the question asks you to draw Lewis electron dot symbol, then you use this one. Okay, now for example, lithium. Lithium 2s will give one electron. You just draw SPDF for lithium and ferrum. Then if move, say contribute electron, so you move 1, number 5. Arrow means result, the process. Lithium will become positive. You just write that lithium positive. Then what is the electron configuration? Become 1s2 plus ferrum will become F negative. What is the configuration? From 5 become 6. So if the question asks you how the electron bonding process happen? Again, what is ionic bonding? You take metal plus non-metal. You refer to the periodic table. You put metal plus non-metal. Then you draw the arrow of the movement of electron. Okay, this is electron configuration. Orbital diagram also same. You move the outer parking space to another non-metal parking space here. You just draw the arrow where does the car move, then the result equal, write positive charge, negative charge, then draw the orbital diagram. The below one is what you're familiar in your chemistry class. You draw the dot. Chemistry one, you don't see the suborbit S. You just interested in the outer electron. One, it becomes stable. Process arrow, lithium positive, don't have anything outside. I don't have anything, don't have external electron outside. Plus ferrum, you need to label as at dot, then negative. Okay, in the test, normally you ask you the first one and second one. This one, no lah. This one in this module, no, do not test you this one. We go into the deeper level because we want to see what happened to the suborbit. Yes. Oh, this one 2p, you don't need to draw lah, actually. Yeah. 2s is got two ma, got two slot here actually. Got one arrow ma. Then you draw arrow, you. Okay. So this one is 5 ma. So 5, 1, 2, 3. You just tell me where does this arrow park. This one go to this space. Then the end result you draw in the far end of the answer. Okay, the rest is just exercise lah. Like for example, NaCl, natrium, sodium chloride. So you find out in the periodic table, Na here, Cl here, same, SPDF, you draw, then you pick in, draw the arrow. So it'll tell you whether natrium will contribute 1 electron. When it contribute 1 electron, what happened to the radius? Become smaller. Then what happened to the chlorium? It become argon already. So it become, the radius will increase a little bit. A bit only lah. Right? Because of imbalance of forces. Okay, the rest of it. For anion, this one is electron charge lah. Is NaCl a bit special. It's called Coulombic bonding force. This is a graph that tell you one equation. How to read this one? Y-axis is force. Okay, one axis is force. Then the x-axis is the radius. Right? Inter-ionic distance A, there is the optimum distance. For example, this one and this one, there is an optimum distance AO. Okay, AO, there is the optimum. When you squeeze two elements together, there is an optimum distance that you can squeeze. You cannot push until all. There is an optimum distance. Where do you measure? From the center of the element, from the core, from the center core. Huh? This one and this one, this is element 1, element 2. There is an optimum distance you can go. You cannot push until all. Huh? So there is a A0. A0 equal to small r plus big R. Okay, this is A0 optimum distance equal to R and R, capital R. R is a cation. Cation means positive charge. R is for the anion. Okay. So how do you read this one? Huh? So there is a repulsive and attractive force. Repulsive and attractive. So what does it mean? Huh? If you this is A, so if you push these two atoms together, if you push, they are repulsive and they are attractive force. Then you combine, it becomes net force. Okay. Now, attractive means you attract electron, right? Which one will attract electron? Cation or anion? Cation, huh? Means positive charge will attract electron. So as you move further to the left, attraction go up for this one. Okay. Then repulsive means you reject. Reject means you already have a negative already. Negative, you will have a magnet. Negative pole, you will pull each other. So repulsive. Okay. So interior distance, A decrease and they become closer. So, but anyway, this is just to tell you how to calculate the thing. So there is a net force 0 here when bonding is formed. We want to find this here. Means the stable states when we combine two elements. We want to find all the force becomes 0, like what you learn in your statics. Equilibrium. We like to find equilibrium. It's this point. Okay. This point is repulsive plus attraction. These 2 points, one positive, one negative, you add together, you get 0. This point, you get AO, the optimum distance between 2. Means the net force become 0. Understand? Huh? Okay. The rest is just extract from this graph. Okay, the rest they will be Fn equal to Fa. So Fa equal to negative Fr. They are opposite force. Okay, it means they are negative force, negative to each other. Okay, this one you have to remember or memorize. F net equal to the front and bottom back. There are 2 forces. The front one is attraction energy. You need to memorize this equation. Then we end the lecture. So negative Z1, Z2, E square divided by 4 pi epsilon O A0 is all these are constant. Z1, Z2 is the radius of the 2 element. Not radius. It's the charges. If one element lose 1 charge, Z is 1. If element number 2 lose 2 charges, means Z is 2. It just mean that. Second one is repulsive energy. You also need to remember. Z1 is you look at the charges. Let's say A negative. A negative Z is 1. And you see, for example, you see the B 2 plus. You look at here, this is the Z value. Z is the number of electron it either receive or give away. You look at this number. Yeah, like B2 plus, right? The Z value is 2. So like this one plus something, you got 2 negative and so on. It depends on the 2 member. But Z is basically you read from the element. Okay, the rest you read. The rest you read. Z is the electron removed or added. So negative signs is different. Okay, that's why there's a negative sign in front. Attractive always positive value. Z can be positive or negative value. So you know that you have anion and cation. One is receive, one is give away. So give away one will be negative, receive one will be positive. So positive, negative value you multiply by the negative, you get positive value. The rest will be given in a question, the constant. So this one you usually you'll be given 8.85 is the permit is a constant. This one is a constant. In the unit of coulomb, square, Newton dot meter. Meter is a distance. Meter square, this is distance, you can cancel. E is it can be joule or it can be Newton. This one coulomb. Coulomb equal to how many EV and so on. So it depends on the constant you use. Same, this one is the same. Okay, what happened to this graph and this graph? You can see the difference. Actually, it's the same meaning. Okay. What is different between this one? This graph is force. This one is force. This equation is for force. Another one is energy. The curve flip already. Oh, and study lah. Got 2 graphs. One is force, one is energy. Equation almost same. If you compare side by side, almost same. You modify a little bit because one is for force, one is for energy. This one become positive, positive. Okay. Still the same attraction energy, repulsive energy, and substitute accordingly. Why? Attraction, you see attraction will be negative energy. When you attract something, you need to let go energy. You receive something, you need to let go energy. Okay. So yeah, for example, forum, you receive 1 electron, it will release energy one. Okay, the rest is just substitution. Okay, this statement is important. Potential energy of the bond is at its lowest, E mean at equilibrium. So at equilibrium is here. Sorry, at here. So minimum. This is net. This is net. So this is in energy minimum when it become equilibrium. This is energy. So you see our energy equilibrium is below -1. Below negative at equilibrium. Look at the forces. Forces equilibrium is 0. Forces equilibrium 0. But for energy, equilibrium will be negative side. That's why when you mix element together, you feel hot. The liquid will hot, become stable. Okay. Rest you read. You just combine. Left is force. Right is energy. So it's just integration of graph. Area under the graph is the energy, so it's force integrate by dr. This is a force, force graph. You integrate this force with the radius, you get area under the graph equal to the force. Same is here. You integrate the force and dr. Okay, so you combine En. This is the net force. Net force, they have attraction and repulsive force. R means this one. This is the R. So R here is attraction. This one is repulsive to infinity. Because you are from the far until you attract to the radius of the molecule or the element. So what you need to highlight here is lower limit always from the far infinity distance until the radius you want to find here. Okay, this one is a thing. Okay, we go for example 5, then call it a day. It's just an application of what you learned just now. You have two elements, magnesium and S. So at equilibrium Newton here, it gives you equilibrium states. Ask you to find the AO, responding interionic distance is AO. AO equal to what? Small r and big R. Means small r and big R. Small r is what? Small r is cation, positive charge. Big R is anion. Anion is negative charge. So from here, Mg2 plus is cation, is small r, S2 negative is big R. So R, this one plus this one equal to the first answer of the first one. Second one, if S2S ion have radius, calculate radius for this one. You find this one, you can solve for B. Now how you find this one? By using this calculation. By using this calculation or this calculation. You see this calculation, this is your A. Okay. Then the C, repulsive force, you put in the equation. So for example, this one A, because the attractive force is not there. So you write F net equal to this equation plus this equation. Front one is attractive. This one is repulsive. So we're interested to find attractive force. Right? So repulsive energy. We calculate the attractive energy first. Because it tells you what? It gives you what? Attractive force. The question already gives you attractive force. So you don't need this component. You focus on this component. Understand? The question gives you attractive force equal to certain value. Use the front equation only because repulsive force is not given. Substitute accordingly. Rearrange this equation. A is here. E substitute accordingly. All right. I'll give you the answer. Okay. Z1 for magnesium is 2. S is -2. How you know the positive negative? Just copy the charges above the element. If it's 2 negative, means -2. If 2 positive, 2 positive. E standard 1.6 10 power -9 column. You substitute lah. E, this one is a primicity 8.8 10 power -2 column. So column and column you can cancel out. Here and here you can cancel. Okay. F attractive was given positive value. Then the rest you substitute and rearrange. You arrive at one answer. FO equal to so and so. Once you have this FAO, you get, oh, sorry, typo error here. Is 10 negative 8, so that you get this answer. Okay, it's typo error. Okay, the number 2, once you have A, you get R plus big R. So 1 is missing. This one is from the section A, this one given. So 1 is missing. You get R for the magnesium. Once you get that one, you can calculate the repulsive force, which is this one. Okay. So you have, in the equilibrium, you have 0 net. This one given in the question, which is negative, this magnitude, minus NB divided by this number. So you not even need to substitute because it's balanced. So this one is, you move this to the another side. Repulsive force is negative 1.49, 10 power 9, negative 9 Newton. So, can I? Okay, example 6, your homework, go and see. Okay, next lecture we do ionic bonding. Okay, we stop here.